Hello everyone, hope you are safe in your place and doing very well to lead yourself towards a progress every day in this pandemic situation also. Hence, to sort out the demand of physics, I am here to help you with. So, why to delay? Let's begin with our first topic that I am going to discuss over this platform is motion in a straight line. That I have already written, that motion in a straight line. So, we will be discussing about the motion in a straight line in this chapter. The total chapter I have divided it into 3 of its parts, and I will be delivering the topic or my discussion in 3 parts of this chapter. The first part today I am going to cover is theoretical discussions of motion in a straight line only. Let's see what covers inside. Generally, the motion in physics, it comes in a branch of physics, can be said as statics, kinematics and dynamics. So 3 branches of physics is there in which we really talk about the statics, that means only the object in rest. We talk about those objects that are in rest. That means we talk about the static objects in the branch of physics that is named as statics. In the very next branch of physics that we say kinematics, we do study the relative motions and all kinds of motions, but we do not mention any cause of any kind of motion, that what brings the motion in a particular object, that we do not discuss in case of kinematics. But if we see the dynamics, in dynamics really we work with the motion, but the cause of motion is also discussed in dynamics. So here our main interest of study is statics and the kinematics. The dynamics, as I have already mentioned, that we need to define the cause behind the motion of the object, and what brings the motion, the cause of the motion, that can be the force, that we are not going to define in this chapter. So let us discuss dynamics afterwards. So in this class we will be discussing about statics and kinematics only. So you see, in our everyday life we measure something, we measure some quantities, in our everyday life, and the quantities that we can measure every day, or we just need of a measure of such kind of quantities, and can be named as physical quantities. So what can we understand from the term physical quantities? Physical quantities are those quantities which gives some measurement to us in our everyday life, that can have a dimension, that can have units also. So the basic knowledge, assuming that you have the basic knowledge about these physical quantities as well as the system of units, that can be FPS, MKS or the CGS, or it can be SI unit also. So assuming that you have the previous knowledge about those topics, I would like to introduce few of the physical quantities in our everyday life. Like you work with length, you work with area, you work with volume, is it? Yes. So the length somewhere is just measured in one dimension. Can you relate what is one dimension? Yes. If I specify the abscissa and the ordinate in such a sense, then 3 of its part can be defined. If I name it as x, then this will be y, and really this is going to be z, and this is our Cartesian coordinate system that we know. So if we are going to measure in the length, only we are restrict ourselves to measure in a particular direction. That can be x, that can be y, or that can be z, but only in one direction that we measure. That's why we also mention the unit of length as meter, sometimes in SI unit, centimeter in CGS units, or sometimes for the greater length we measure it into kilometer, or sometimes we measure into light year also. 1 light year. Light year is a unit which actually tells that in a year how far the light can travel. That we know the speed of the light, that is 3 into 10 to the power 8 meter per second. So in 1 second light travels around 3 into 10 to the power 5 kilometer. So can we assume that what is maximum speed that we are having around us? And if the light travels for a year, how far distance it can go? In 1 second it can go 3 into 10 to the power 5 kilometer per second. So if in 1 second this much kilometer it can go, then really in a year how far it can go? That long or very long distance is measured in the unit of light year sometimes. Well, we will be talking about it in class 11 again. So the next quantity that I have written is area. In mathematics, you have worked with the surface area and the chapter of volume, perhaps. So there you have found that areas are measured in meter square, areas are measured in centimeter square, or it can be measured in hectare or something, right? And the volume that are measured in meter cube, centimeter cube, etc. So can you find something, can you relate something here? That the length, as we are mentioning the length along a single direction only, that's why what is the power over m? That is a meter here, that is 1. Nothing is there, that is 1. That restricts ourselves towards one direction only. Fine? So in area, we mentioned meter square. Why it is meter square? It actually signifies that we are working with two dimensions. When we are using length, we are working with one dimension only, and when we are working with the area, we work with two dimensions only. The volume, if I say that we work with volume, then what is the work of volume? Sorry, what dimension this volume is taken? It is in 3 dimension. That means, if you can recall the formula of a rectangle, the area of a rectangle, the formula for area of a rectangle is measured as length into breadth. If it is the length of the rectangle and this is the breadth of the rectangle, then the area is measured into length into breadth. But if I specify what is volume, volume of a cuboid is measured as length into breadth into height. So in defining so, you can find that the length along a certain axis and the breadth along a certain axis is taken. Fine. So if I talk of a cuboid, if I really talk of a cuboid in this sense, then I will be talking about the length, the breadth and the height. These 3 dimensions are applicable here. So in mathematics, everyday life mathematics, we just talk about 1 dimension, 2 dimension and 3 dimension. But here in this chapter, actually we will keep ourselves upgraded to 4 dimensions. Yes. Now you will be a little curious to know about 4th dimension. What makes the 4th dimension here? What can consist this 4th dimension? You very well know what can be specified. If I specify some point in space, it can say, it can have a coordinate of x, y, z. Is it so? Yes. Suppose, let me mention a frame is there. Let me mention a frame is there. This is x, this is y, this is z. And hopefully they are positive axis, and the x-axis is taken as, the negative x-axis is taken in the back of the board, negative z-axis and negative y-axis. So let us consider that this is our center, the origin, and if I specify any kind of point here in the space, that means to go or to reach in this point, particularly how I need to travel. Firstly, I need to go along the x-axis at a certain distance, then I need to travel along the y-axis to a certain distance, then I need to go towards the z-axis. So thrice I need to change my direction. So after changing twice the direction, I actually reach to my point. That means I have walked over 3 distances or 3 directions to reach to a particular point in a space. That's why if I have moved x unit along the x-axis and y unit along the y-axis and z unit along the z-axis, then our coordinate will be specified as x, y, z. Now this is very general that we study in mathematics. But if you assume the everyday cases that occurs, that is contained within the motion, chapter of motion, like a moving bus is there, a moving bicycle, or you are playing football, you are running with the football in the ground. Let yourself think. What comes in your mind? When you are just running with the football, or suppose you jumped over something, what you are doing? You are just changing your position. You are just changing this coordinate. That coordinate which I am specifying here, this coordinate you are just changing by jumping. And when you are jumping, the coordinate is changing. For say, your coordinate was firstly fixed at x1, y1 and z1, and when you jumped, your coordinate is just taken into x2, y2 and z2 direction. But have you noticed that to jump over something, you need time. What is required? Time is required. So here in this Cartesian coordinate system, we are unable to draw the 4th dimension, but if we want, we can include another dimension, that can be the time. If I freeze yourself, if I freeze you, suppose you are jumping over some wall, and if I freeze you at particular time, can your coordinate be changed? No. So if I leave this, if I say statue, your coordinate will not be changed. But if I say, okay, resume, just you jumped. To jump over the wall, you take some time. Let us say t time is taken. It can be 3 seconds, 4 seconds, 2 seconds, whatever. It depends on different cases. So I mean to say that we can actually include the time as another dimension to relate the different objects that are in motion in our everyday life. Suppose a gas particle, or let us take a very common example, that inside your room you might have noticed that mosquitoes are flying all around you. Sometimes it will say, it will sing around your ear. You are just about to slap your own chin and it will fly there. So what it is actually doing? I can guess that the mosquito is here. That means it is in the position of x1, y1, z1. But when the mosquito is flying here over here, while flying this distance, it takes time. Is it or not? Yes. If it has taken the time, so if I can include the time as an axis, but that kind of axis is going to be virtual for us. I am unable to draw in this Cartesian coordinate system, but we can consider ourselves that, let us assume that when the mosquito was here, at that time the time was t1. So can I change the direction or the coordinate in this way? Can I change the coordinate, or can I represent the coordinate in this way? x1, y1, z1, t1. And when the mosquito has fly to this point, it has changed to x2, y2, z2, t2. At t2 time it has reached in this point. That's why I have mentioned t2. So you can think that not only the coordinates are changing, not only the position coordinates are changing, also the time as a coordinate, if it is involved in motion, that can also be changed. So very well, we take the example of 4D for the discussion of motion here. But here one thing is mentioned, that our chapter name is motion in a straight line. So keeping ourselves restricted to only one dimension, that means a position dimension if I take, then this will be along with a straight line, along in a straight line. That means all the directions, if I take in a certain way, it will be a straight line. So how and why the chapter is said, and how the chapter will give itself that the motion in a straight line, that we will be discussed now. So you have got the differences between rest, the object in rest, and the object in motion. So what can be the definition of an object being in rest, and what can be the definition of an object being in motion? That can be like, if the object, suppose the mosquito is here, if the mosquito is here, it is just flying here over time. You are just observing the mosquito when it is flying, and as the time is passing by, you can see the position of the mosquito is also changing. That is denoted by motion. That is denoted by motion. When over time the position of a certain object will be changed, that object is said to be in motion. But if you give the mosquito something like that, and suppose you have killed the mosquito, so you will be leaving the mosquito here over your desk, suppose, whether this mosquito, if it is dead, whether it will be able to fly? No. Now you observe for an hour. You see whether the mosquito can be able to just change its coordinates for x1, y1, z1 to x2, y2, z2 in this way? No. So we say the mosquito is at rest, or we say the dead mosquito is at rest. So this is the basic difference between rest and in being in motion. So whenever we just change our position with respect to a particular point, and now it is very good to discuss about reference point. What is reference point? What is reference point? Reference point, suppose if I say, like a wall clock is there just in front of me, and a poster is there, and the door, suppose the door and the wall clock, both are there in front of me. Now if I measure my distance compared to that door and compared to that wall clock, will it be same? Will it be same? Can be or cannot be? Now for the case that I am having, suppose, let me mention over here, suppose an object A is here and another object B is here, and I am sitting in this position. I am sitting in this position. Suppose I am sitting in this position. So with respect to A point, how far I have said? With respect to A point, let me say that it is 3 meters apart. I am sitting. But whether you are getting the same distance between me and the B point, no, it can be different. It can be different. In this figure, we can see that the distance is much more than compared to the distance between me and the point A. But here, in the distance between me and point B is just greater. It can be like 5 meters per se. Okay. So what I mean to say is, what is reference point? Reference point is that point with respect to whom we measure a particular object, or we measure the position of the particular object. Okay, so this is me, I am the object here, over here, and what is my position with respect to reference point A? That is 3 meter, and with respect to reference point B, that is 5 meter. So suppose a man is standing far away from me, and he is standing at point C. So will it be the same? Will this distance be same? No. So if the man is watching me that I am sitting in a place, or I am just walking, so what the man will observe, what the man will calculate the distance, the same thing, the man is standing at a C point, and the man, whatever he is just analyzing, that cannot be analyzed by the man standing at B point. They will say it differently. So whenever the frame of reference or the reference point gets changed, we say that the measurement can also be changed. But whenever in laboratory we perform some of the motion experiments, we restrict ourselves to the corner of the laboratory room as the reference point, and then we start doing our practicals. Fine? So hope this is clear. Now we'll be talking about the motion along a straight line. How this motion can be made along a straight line? How this motion can be made along a straight line? Think logically. If I say I am in space, the mosquito is in space. Suppose the mosquito is in space. That means the mosquito is having the position x1, y1 and so on. 3 of its coordinates are there. I can't say that it is traveling along a straight line. Can I say? It can be said, man. It can be said. Like suppose the mosquito was here and mosquito has shifted to this place. Suppose. So the distance between these 2 points is always a straight line. That means if I assume that the mosquito was here and mosquito finally has shifted over this place, then if I connect the 2 points, definitely this is going to be the straight line for us. Definitely this is going to be the straight line for us. So we will be restricting ourselves with such kind of motions only, where the motion of the object is restricted over a straight line, and to do so we call some quantities, we define some quantities like displacements or distances. What is displacement now? So if we see that physical quantities are there, so we are measuring different kinds of physical quantities. Physical quantities can again be divided into 2 of its categories. In what category it can be divided? It can be divided in the categories like scalar quantity and vector quantity. What does this mean? What does this mean by scalar quantity? What does this mean by vector quantity? The scalar quantities are those quantities which only deal with the unit, and the measurement. Unit and the measurement, which only have unit and the measurement. Firstly they will have unit, and secondly they will have measurement, or you can say firstly they will have measurement, then they will carry 1 unit. Like some length I have specified. I have said a stick of 5 meter. A stick of 5 meter. I have said the length of the stick as 5 meter. So this 5 is what? 5 is just measurement, and what is unit? This meter is a unit. And if I specify in this way that Ram is moving along the road or moving, and while moving he have covered a distance, of suppose 10 meter. I do not know what kind of distance he have covered, whether he have gone like this and this way, or whether he has gone in a straight line. I do not know really how he have gone, but the total distance that he have crossed in last few seconds is just 10 meter. If I need to deliver such quantity, then I need 2 things. First is measurement, and then I need to specify the unit. That means the scalar quantities only have magnitudes. The scalar quantities can be said to those quantities which are having only magnitudes. But if I specify some quantities like the Ram, firstly he was going along this way, the initial position that is A point and the final position of Ram that can be specified by B point. So Ram, when he was walking over A to B, he have gone 10 meter and I have taken it along as a distance. Whether I have specified here that Ram has a certain direction of traveling? No. But if I want to mention that Ram has gone along a straight line, then what I have to do? I have to take the shortest distance between its initial point and the final point. So what is the shortest distance between the initial point and the final point? That is going to be the straight line for us. That is going to be the straight line for us. And this straight line over distances, we define it as displacement. The total measure of this straight line, that is the shortest line, the shortest distance between the initial and the final point, is specified as displacement. And as we are telling that it is the shortest distance, that means it has a particular direction. What it can have? It has a particular direction of traveling. Firstly, Ram was going along 10 meter direction, and how it was going, like this and that, this and that. So in the previous case, when Ram was covering a distance of 10 meter, and we were working with the distance only, we did not acknowledge ourselves with the direction in which he is traveling. Firstly, Ram was traveling in this way, then he turned, he changed his direction, again he went little, and then he again changed his direction, and finally he had reached to the point B. But if I specify the direction that in between the final and the initial point, if I specify that how Ram has traveled from A point towards the B point, and that shortest distance for say, that can be like 7 meter for say. So here from this example, you can get that what a motion was not in a straight line, we have made it into straight line with the help of a quantity named as displacement. And such kind of quantities, while defining, I will define in the sense like displacement is equal to 7 meter, and also in bracket we specify that from A to B. What does it mean? That means Ram, if instead of going by this 10 meter distance, Ram could have gone by this straight line, he had to travel only 7 meter. So this is the way as how we acknowledge with the motion in a straight line. So whether the motion in a straight line is there or not, we do not know. Whether the motion is along the zigzag path, it doesn't matter at all. But if we only take or only choose the final point and the initial point of the object, then the shortest distance between the initial and the final point will be summarized as displacement. And such kind of quantity which have measurement, which have units also, and which specifies the direction along this information are said as vector quantities. Is it okay? Assume it is okay. So what is the basic differences between displacement and distance now? Distance and displacement. Let us see very nicely. Suppose Rohit is a boy to whom I have said that you just go from point A to B around the pond. Then again from B point you go to C point and you stand. And the pond structure is something like rectangular. Then definitely the angle between A and B will be 90 degree. And now if I specify the distance between A point and B point as 5 meters and the distance between B and C point as 8 meter, then how far Rohit has traveled? From A point to C point? It is that first he had gone 5 meter, then he had gone for 8 meter. So altogether he have gone for 5 meter plus 8 meter is equal to 13 meter he have traveled. But notice very nicely that when Rohit was traveling from A point to B point, if I specify the direction as this, like the upside is north, as you specify the direction in a map, the upside is north, downside is south, this is east, and this will be west. So firstly what Rohit has done? Rohit started from A point and Rohit has traveled to the point B. That means from north towards south direction Rohit has traveled by 5 meter. After reaching at point B, Rohit turned away by 90 degree and he traveled a path of 8 meters to reach in the point C, and that distance he had traveled towards the east from the point B. So firstly he was going towards south, but then he changed his direction towards the east. So twice he had changed his direction, or two kind of directions he had taken. Now if I need to specify the motion of Rohit along a straight line, how can I specify? Can I specify by this line, this length like A to B then B to C as a straight line? No. I cannot specify the motion of Rohit is from A to B and B to C as a straight line. So to absorb the total case into straight line condition or in one dimension, we need to involve the displacement. We need to involve the physical quantity known as displacement. So what will be the displacement here in this case? Here in this case the displacement will be the shortest distance point A, shortest distance between point A and point C, and that we can find out with the help of Pythagoras theorem here. So that is going to be like hypotenuse is equal to root over of perpendicular square plus base square. So this is going to be 5 square plus 8 square is equal to root over of 25 plus 64 is equal to root over of 89. So this root over of 89 is the distance between point C and point A, and this distance instead of 30 meter if we use, then we will be using the displacement. And now if we specify displacement, that means we have a certain direction. So can you count in which direction Rohit has traveled? Rohit started from A point, finally we have reached to the point C. So A point, C point with respect to A is in the due north towards the east. From due north towards the east, in this sense we can say. From north towards the east we can say. That means from north point towards the east point Rohit has gone. In this manner we can specify. So this will be the advantage of displacement over distances here. The distances will be the total distance through which the body has traveled, but displacement is the shortest distance point, the shortest distance between point A and point B or point C. So the basic difference between distance and displacement is distance is scalar quantity and displacement is vector quantity. Distance cannot be zero if an object is in motion, was in motion, then its distance can't be zero. But displacement, if it is required, it can be zero. How? Let me specify. The same thing that Rohit has started his journey from A point to B point and then B point to C point. So if I instruct Rohit to come back to a point D, which is also 90 degree, and this is the pond, around the pond he is just walking over, and he has reached to the point D. Now if I am specifying here, if this is 5 meter, then this is also 5 meter, and this will be 8 meter because this is a rectangular shaped region. And then if Rohit has traveled from A point to D point, then what is the total distance traveled by Rohit? Total distance traveled by Rohit is 5 plus 8 plus 5 meter. Is equal to how much? 18 meter. But what is the displacement? What is the displacement here? The displacement is equal to only 8 meter towards A to D, towards D. 8 meter towards D. So we need to specify the direction also, toward D from point A. So this is the basic difference between distance and displacement. Now if I instruct Rohit to come back to the position A, then what can be done? What will be the situation? If Rohit come back to the position A again, means he has started from A, he has gone to B, then he has gone to C, he has came to D, and from D he has again came to his initial point, that is A. That means total journey, in total journey he have traveled a distance of 5 plus 8 plus 5 plus again 8 meter. That means in total 26 meter he have traveled. But now if I am going to define the displacement, then displacement, as per the definition of displacement, it is said as the displacement is the shortest distance between its initial and the final point. So when the initial and final point are same, then the displacement will be 0. So in this case displacement will be 0. So in this way we can assume, or we can just make a point here, that distance can never be 0 for an object that was in motion, but the displacement can be 0. So in this way we can summarize ourselves that distance can be equal to displacement. Distance can sometimes be equal to displacement. And when it will be equal to, like Rohit has traveled from A point to B point. Then in this condition, how far Rohit has traveled? Rohit has traveled by distance of 5 meter. So here, what is the total distance? Total distance is 5 meter. And what is the distance between the initial and the final point? The shortest distance, that is also 5 meter. In such a case, the distance can be equal to displacement. But in other cases, distance will be just greater than displacement. In other cases, distance will be just greater than displacement. So this you have to keep in your mind. Now, different kind of motion that we study in our everyday life, and what kind of motion that we are going to study in this chapter, or we will hold our interest over, is the uniform motion. That means the motion, its type, if we are going to divide, then it can be like uniform motion and non-uniform motion. So what is uniform motion? Uniform motion. Which motions are said as uniform motion? First, you make your point out that what is motion. What is motion? Motion means an object changing its position over time is said to be motion. But when we will call the object is in uniform motion, and when we will call the object is in non-uniform motion. To do so, or to define it so, we define uniform motion as those motions where equal distances are traveled in equal interval of time. Such kind of motion is said to be uniform motion. Now let us assume an example here, that a ball is rolling over the floor. A ball is rolling over the floor. The ball is just rolling over the floor. And when we have observed the ball was here at point, say A. We have started counting the time. The time was 0 in an instant. The time was 0 second. After 5 seconds, we have analyzed the ball has reached to point B when the time was 5 seconds. And after 10 seconds, we found that the ball is at position C. After more 5 seconds, that is after 10 seconds, the ball is here. So at a gap of 5 seconds, we are analyzing the case. We are analyzing the ball position of the ball. Okay. So after more 5 seconds, let's say after 15 seconds total, the ball's position is at B. Now with respect to A point, if B point is at a distance of suppose 10 meter, then what can we specify? We can say that in first 5 seconds, the ball has traveled a distance of 10 meter. And in similar way, in the next 5 seconds, that is from B point to C point, that is 5 seconds or not, the total time is 10 seconds and the B point is at a distance of 5 seconds. So the distance, the time distance between the total difference between the time is 5 seconds. And in this difference of time, if we represent the ball, if we say how far the ball has traveled, and if we check and it is found to be 10 meter, and very soon in the next 5 seconds also we find the ball has traveled by more 10 meter, then we need to get here that the ball is a uniform motion. Why? Because the ball is just passing over equal distances in equal interval of time. Okay? Equal interval of time. Suppose you are just walking, or you are just doing jogging in the morning. You just woke up early in the morning and you went to the roadside for jogging, or in the field for jogging. So you are just doing a jogging in your sense. When you are doing jogging in your sense, you will maintain a fixed speed. What is speed? That we are going to define now. So you will be having your own speed, or suppose you are just taking equal interval of time to travel equal distances, or in equal interval of time. Suppose in 1 minute you are covering a distance of suppose say 100 meter. In 1 minute you are covering. Okay. So in the very next 1 minute also you are going to cover the next 100 meter. In a way you are covering, that means your motion is in uniform motion, but suddenly you do not know your naughty friend have came for jogging and he found you, and suddenly while jogging behind you, suddenly he came and you are jogging in your sense, you are in uniform motion, but from the back side he pushed you because he is too naughty, he can. So once he has pushed you from back side, now your speed will increase or not in a sense, or you will travel faster or not. You think when the force is applied on you, you will travel a little faster in the sense. Now what will happen? There will be a disturbance. Like in first 1 minute, duration, you are going from A point to B point, and in the same, say for next 1 minute, you were going from B point to C point, and these points are at a distance of 100 meter for say. But when your friend has pushed you, now you have started in the first 1 minute, you were just going 100 meter from A point to B point, and when you were in B point, your friend pushed you, and in the next 1 minute, such that your friend will be unable to hold you again or to get you again, you just started walking over, you started running over speed, and you covered a distance of 150 meter in the next 1 minute. Then what kind of situation is really organizing here? Here the case is that the time remains the same. Firstly, the time was 1 minute and 1 minute, first 1 minute, then second 1 minute. Here also the time is same, that is first 1 minute and second is another 1 minute. But in first 1 minute you have traveled 100 meter previously, and in next 1 minute also you had traveled 100 meter previously. That was said as uniform motion, because you were traveling equal distances over equal interval of time. But now you are not traveling the same distances over an equal interval of time. The time will remain the same. Time is the same. 1 minute, then 1 minute. But your distance that you are covering is not 100 meter now. Firstly it was 100 meter, then it has changed to 150 meter. That means you are not covering it uniformly. That means such kind of motion will be said as non-uniform motion. Non-uniform motion. So hope this is clear to you that what kind of motions that we study here in this chapter is uniform motion and non-uniform motion. Now, as to discuss this condition, I was taking help of a quantity that was speed. So let us define the speed now. What is speed? What is speed? Generally, speed is said to those quantities, or speed is that quantity which measures the rate of traveling, or we can say time rate of traveling. If I say that a path length of 100 meter is covered in 1 minute, then what is the total distance that is covered, that is 100 meter, and what is the total time that is taken to complete is 1 minute. Then it will be said that the speed of such kind of object is equal to the total distance traveled divided by total time taken. So total distances traveled is equal to how much here in this case? 100 meter, and total time taken is equal to 1 minute. But we need to take care of our units also. So as the above quantity is in SI unit, we also specify the time in SI unit, that is 60 second. That means second is the SI unit of time. So what we are going to find out? 10 by 6 meter per second. Means in 1 second 10 by 6 meter the object is going. So this is going to be as specified as speed. That means how far distance is traveled in a certain time is specified as speed. Or in the language of mathematics, we can specify that when the object was at position here, say x1, the time we saw in the clock was t1, and when we have checked the clock, the time was t2, and we found the object in the position of x2. Then what is the change of points, what is the change of the distance or what is the change of the time. The total change in the distance was found to be x1, x2 minus x1. This is the total distance. And what is the total time? The total time is t2 minus t1. This is t2 minus t1. Then if we really need to specify speed, then we will be defining the speed as x2 minus x1 divided by t2 minus t1 in this sense. So this ratio of path length covered divided by time, the ratio of the path length covered to the time is said as speed. It is said as speed. Now, which kind of speed will be said as uniform speed or which kind of speed will be said as non-uniform speed? Speed, suppose you are covering, let me take the above example again. In the first time, in the first sense, in this case, suppose in this case that we had assumed that in the first 5 seconds you are going 10 meter and in next 5 seconds also you are moving with 10 meter and very soon in the next 5 seconds you are going more 10 meter. Then how was your speed? The speed was 10 meter by 5 seconds. So in that case your speed was equal to 10 meter, sorry. So in this case your speed was equal to 10 meter divided by how much second was taken? 5 seconds. So if I cut, it is coming as 2. So 2 meter per second was the speed of the vehicle or speed of the object in this case. And such kind of motion is said to be uniform motion. Why? Because the object from A point to B point, the speed remains same. If you count for each of these segment, that is from A to B, from B to C and from C to D, then for each of the segment you will get the same speed, that is 2 meter per second. That's why when the motion will be uniform, at that time equal length will be covered in equal time interval, and that will be said as even the uniform speed is maintained. But if it is not being so, the non-uniform motion will get involved and the speed that is involved in non-uniform motion will be said as non-uniform speed. So what will be non-uniform speed? The non-uniform speed will be defined for the very next statement, that is in this case. In this case we can find in between A and B position, if we are going to find the speed, then our speed will be equal to, in case of the position A and B, if we are going to find the speed, then such speed will be defined as 100 meter by 1 minute, that means 60 seconds, that is equal to 10 by, or we can specify 5 by 3 meter per second in the first case, in the first segment. But in the second segment you will find the speed is not the same. Now the speed will get changed. And how it will get changed? It will get changed by the term like 150 meter divided by 1 minute, that is 60 seconds. In the previous case that speed was 10 meter per second, 10 by 6, that is 5 by 3 meter per second in the previous case, or in the case of this A to B we have found. But in the second case, that is from B to C, we are just getting 5 by 2, that means 2.5 meter per second as the speed. So the speed is not similar in these two cases. Firstly it was 5 by 3 meter per second, then it has just increased to 2.5 meter per second. So in this case we can say that the uniformity in the speed is not maintained. That's why such kind of speed will be said as non-uniform speed. Fine. Now besides defining the speed, we need to specify another quantity on the basis of this displacement. We will call that quantity as velocity. We will call that quantity as velocity. So what will be the velocity? What is velocity? The definition of velocity states as that the ratio of shortest distance traveled by the object in an interval of time. that means, or we can specify in this sense also, that velocity is equal to the ratio of shortest distance. And what is shortest distance? The shortest distance means the displacement which have a direction, so that will be the total displacement divided by total time taken, so this is going to be the velocity now. So if we represent velocity by the term v, and if we represent the displacement by the term s, and if we represent the time by the term t, then this is going to be our first formula in the chapter of motion, that is v is equal to s by t. And do not forget that this displacement is a vector quantity, hence any kind of vector quantity and time being the scalar quantity, so vector quantity divided by scalar quantity is always a vector quantity. That's why this velocity v will be a vector quantity. And if you need to specify any kind of vector quantity, you can put just an arrow over it. We'll be clearing this doubt in class 11 once we come. So the velocity is equal to speed by the distance, displacement by time taken. In case of speed also, the distance traveled by total time taken, we had said. So what is the very basic difference between this speed and this velocity? You see, let us take an example now. I said that Rohit traveled from a point, our familiar example that we had taken previously, that will make you help you in understanding better. That's why I am taking again. So from a point to b point, Rohit was traveling 5 meters. So let us say that when Rohit was traveling from a point to c point or b point, when Rohit was traveling from a point to b point, he had gone 5 meter, then he had gone for 8 meter, then he had gone for more 5 meter. So the total distance, if I calculate by the term d, if I signify it by the term d, then total distance traveled is just 5 meter plus 8 meter plus more 5 meter is equal to total 18 meter. And I said, let us mention that the total time taken by Rohit in covering such distance is just 2 minutes. Let us say 2 minutes. So what is the total time? Total time is 2 minutes. That means 120 second. In second if we convert, it will be 120 second. So in this case, if we measure the speed of Rohit, what was the speed of Rohit? We are going to measure the total distance, that is 18 meter. We will write here 18 meter. And what was the total time taken? The total time taken was 120 second. So this 18 by 120 is going to be the speed for Rohit. But if I really need to specify what was the velocity of Rohit, then as we mentioned this velocity as a vector quantity, that means we need to measure the speed in a certain direction. Now we will be measuring the speed but in a certain direction. That means from A point, that is the initial point, to the B point, what is the shortest distance we will calculate. And this shortest distance, as you know, this is, sorry for the interruption. As you know that from A point to B point, the distance is 8 meter. So the total distance in between initial and the final point is 8 meter. So in measuring the velocity, this displacement will work now. The total displacement is 8 meter. And total time, the time will be same now. Now you will not think that how much time it will take to travel from A point to B point straight away by 8 meter. No, that time you will not calculate. The time will be same. Because Rohit has not gone by the path A to D straight away. He had gone firstly to B, then C, then he had reached to the point D. Okay? So, the velocity here in this case will be 8 meter divided by 120 second. And finally, the thing that comes out is just less than the speed. That you can see that 18 meter by 120 second is just greater than 8 meter by 120 second. So our velocity will be less in this case. Why? Because we are defining velocity in terms of displacement, but we are defining the speed in terms of distance, because speed doesn't include any kind of particular directions, as we define speed as a scalar quantity. But if we relate some direction along with some speed, then such kind of speed along with the direction will be called as velocity. That means there is a very short difference between velocity and a speed. That is, velocity is equal to speed, but in a certain direction, certain direction, the direction you need to count, take in your consideration. Okay, so the speed in a certain direction will be said as velocity. So this is the basic difference between speed and velocity. Now we are in a stage to define the instantaneous velocity and the average velocity, or instantaneous speed and the average speed. Two kinds of speed there can be. We can measure the speed in two ways. One is average and another is instantaneous. Now you think yourself, when we are talking about the average speed, let us say average speed, then what does it mean, this average speed? The average speed will be said to the speed which deals over the total distances covered. Suppose daily life example, let me take. Suppose I just walk out of my home and I just walked over a distance and I found my friend in the way. I was going towards the market, but I stopped as I met my friend after a long day. I'll be waiting there for a couple of minutes, suppose. I'll be gossiping, and then again I will start moving. And at that time, I got another person. Again I will stop. Again, suppose I need to see, again if I see that suppose I am getting late, then what I will do? I will increase my speed now. I will increase my speed and I will move to the market finally. So what I have done, firstly from a point I have gone to point B and I stood up. I wait for a couple of minutes there while gossiping with my friend at point B. I just walked over another distance. Which may or may not be equal to the previous one. Previous distance, that is the distance between A and B. Then in the next distance, suppose I took less time to cover. In first 50 meter, I took around 1 minute. In the next 80 meter to cover, I took around 50 seconds, suppose. Then what can be said? Then the speed, if I say, or if anybody will specify what was my speed in the entire duration of my journey, then the speed will be calculated in such a manner, like the total distance traveled that is equal to 50 meter plus 80 meter, that is equal to 130 meter over the total time taken. So what is the total time taken? 60 seconds. So 1 minute is just taken into 60 seconds plus 50 seconds again. That is the total time is 110 seconds. Now if you are going to define average speed, that is going to be said as the total distance traveled, total, I am writing here total distance, I am writing the short, distance traveled divided by total time taken. And in this case you will find that average speed is equal to 130 meter, that is the total distance, divided by total time taken, that is 110 second. So what will be the speed? The speed will be 13 by 11 meter per second. So in this case we are calculating the average speed because we took the total path in our consideration and we took the total time taken to cover the distance in our consideration at once. That's why it will be said as the average speed. Okay, but if we need to specify the instantaneous speed, what we need to do? If we need to specify the instantaneous speed, suppose let me introduce one example here. Your friend is just riding a bike and you are sitting at back, as a pillion rider you are sitting. So suddenly you thought of checking the speedometer of your friend, that how much faster he is just moving with his bike. And upon his shoulder you just checked in this way, suppose what is the speed, and you saw the speed is 90 km per hour. So how much time you took to observe it? It is very less than a minute also, less than a second also. You just saw. This is very less than a second also. That means we can say that the time is being very shorter. The time is being very shorter. And when you saw what was the reading and in that speedometer, that was the instantaneous speed. And why do we call it as speedometer? Why not the velometer? Because it doesn't measure the velocity. Because velocity is also the speed, but in a certain direction. Now if we fix some meter in our vehicle to get the speed, then how we will be knowing that in which direction the vehicle will go? Until and unless we just observe its motion. So we say it as speedometer. If we go along a straight line, then definitely our distances that will be traveled, that will be equal to displacement. In that case, the speed will be equal to velocity. But if the vehicle is going in a zigzag path where continuously change in the direction will be there, still the vehicle's meter will measure the speed. Such kind of speed is measured, and that will not be the velocity. That's why the meter is said as speedometer, and it gives you the measurement of speed of the vehicle instantaneously. Means in that second of time, what is the speed in your vehicle, that you can see. That very pulse of the second, what is the speed in your vehicle, that will be said as instantaneous speed. Means suppose in case of the previous case, while dealing for my case of average speed, I said I was moving towards the market and I stopped in the middle at point B. Then again I started moving in this way, and entirely I took around 1/10 second. Now the distance, if I see A to C point, it is not less, and even the time that we have taken in our consideration, that is 1 minute and then 50 seconds, they are not less even. They are a good quantities of time that can be measured. So the total time was greater in this sense. But if I specify that I am here when the time in a clock is suppose 10 p.m. 35 minute and 15 second, in the clock it is showing. So what is the second? 15 second. And before it has reached, the time has reached to 10, 35, 16. Before it reached to this time, that means very less than a second also. If I need to check the displacement made by my vehicle, that can be very short, that can be very less. Such kind of small distances or small displacement measured in very tiny time is said as instantaneous speed. So instantaneous speed is the speed what we observe instantaneously, means in a fraction of second, or when the time is going to be very low, such that the distance traveled by the vehicle will be as much shorter as it can. That means there will be no difference between the distance and the displacement in this case. In such a case, we will define the instantaneous speed, and assuming so, we can say that instantaneous speed can also be equal to instantaneous velocity, because when the time limit will be very short, in the very short amount of time, can the vehicle go very long distance? No. Can the object go very long distance? No. It have to go a shorter distance, and if you have to go the shorter distance, there will be no difference in the distance and the displacement in that case. And there we will find the instantaneous speed or instantaneous velocity as well. So in this way we define average speed and average instantaneous speed. And now if you will say for the average velocity, what will be the average velocity? Then in case of average velocity, we can mark it as the total displacement. Now as we are just working with the term velocity, we will be taking the help of displacement. That's why total displacement traveled, total displacement occurred in total time taken will be said as the average velocity, But what will be the instantaneous velocity? That instantaneous velocity will be equal to instantaneous speed that we had defined previously, just few minutes before. What we have defined about this instantaneous velocity speed can be equal to instantaneous velocity, because when the time limit will be very small, suppose this fraction of second is measured in delta t, okay, this very short fraction of second is measured in delta t, and this delta t is as much smaller that can be compared with zero, that means it is about to be zero. That means it can be like 0.01 or 0.002, like that kind of quantities, but not zero at all. I'm not specifying that delta t is 0. No. But delta t is as small that it can be taken in our consideration, and if we approximate, then we will take 0. For such kind of very short amount of time, if we say the object has traveled from this position to this position, then what will be the total distances traveled? That total distances traveled, let me specify by delta x, and delta x will not be so longer, no? In this case, because the time is very shorter here. So such kind of distance will be equal to displacement. Why? Because when we see a curve if we divide a curve into certain small pieces, then really such small pieces we can say as, or we can work with as a straight line. That we will acknowledge ourselves in class 11 again while reading the same chapter but in a new sense. So at that time we will be talking about this thing again. So what will be the instantaneous velocity? The total instantaneous velocity will be equal to delta x divided by delta t, and mentioning the limit of delta t, that means the limit of the delta t will be 0. That means the time limit is very short, that is for 0. That will be the measure of instantaneous velocity. So hope you get this video, you find this video as useful for you. And the last topic in our discussion, theoretical discussion of the chapter motion in a straight line, we will see what is a new quantity said as acceleration. So we are going to introduce another new quantity, which is acceleration. So what is acceleration? Suppose, as we have talked about the speed and velocity, here I forgot to mention you the unit of speed and velocity that was about to come as meter per second. No? So you always there is SI unit will be meter per second, and if you take the CBSE unit, then it will be centimeter per second. In case of velocity also the amount will be similar, the centimeter per second. So what is the basic difference between speed and velocity? That we have already mentioned, that velocity is the speed but in a certain direction. So we need to involve the direction along with the speed parameter, then only the speed will be said as velocity. So in case of speed and velocity, we checked that when it is uniform speed, when the speed is uniform or when the velocity is uniform, that means if I am just moving with the velocity of 60 km per hour in my bike and continuously for long 3-4 hours I am moving with the same speed without changing any kind of speed in my vehicle, then it will be said as uniform speed. But if I need to make a brake, then my vehicle will slow down automatically. If I need to accelerate myself, or if I need to go more faster, then I have to trigger the accelerator. There only the term comes accelerator. That means we accelerate. That means we can get the situation like I was traveling by bike, my speed was at 60 km per hour. Now I am changing my speed from 60 km per hour to 80 km per hour because I need to go a little earlier. I need to go in a hurry. I have less time in my hand. Suppose such kind of situation comes in our everyday life. So at that time what we do, we just throttle our accelerator of the vehicle. And when we throttle our accelerator, there you can see the changes of speed in your odometer reading in your vehicle. That in a certain time only, within few seconds only, your vehicle will shift from 60 km per hour to 80 km per hour. Now what is happening here? There we are finding a change in the speed. So what is found? A change in the speed. And if we say that our motion is along a straight line, that means the speed is equal to velocity because we are moving in a certain direction. So the speed along a certain direction will be said as velocity. That means we will be finding some changes in the velocity. What we will find? We will find some changes in the velocity. So in the prior case, we found the vehicle was at 60 km per hour. Let me say the velocity was v1, or let me say the velocity as vi. That means initially my velocity was vi, that is 60 km per hour, and finally my velocity within few seconds of time, suppose in 5 or 6 seconds, suppose in 6 seconds I have shifted my vehicle with a speed of near about 80 km per hour. So what is this kilometer per hour? This is the unit of speed or velocity, right? So here you can see that what happens in our everyday life, in such kind of small seconds only it can accelerate. So what is happening here? There we can find the change of velocity. That means the velocity was vi firstly and it has shifted to vf now. That means we can find a change in the velocity. That is delta v we can specify. What is delta v? Delta v is just specifying the change in the velocity. So what is the change in the velocity? That is vf, v is velocity final minus velocity initial. That is going to be the change. And what is the change in the time? Total change over the time is delta. It can be seen as t only. So the total change of time is given by del t. So the parameters of Vf minus Vi is just 20 km per hour. Why it is 20 km per hour? Because it has shifted from 60 to 80. So 80 minus 60 will be 20 km per hour. And what is our total time taken? Total time taken is equal to 6 seconds. In this case, what has been done? We say that we need to accelerate ourselves. We need to accelerate means we need to increase our speed. What we need to say? We need to increase our speed over a particular interval of time. Okay. So the acceleration is the measure of change of velocity with respect to time. That means the ratio of change of velocity to that of time is said as acceleration. So acceleration is equal to the change of velocity, the rate of change of velocity, or we can say the time rate. Why the time rate? Because we are dividing the change of velocity with respect to time. That's why we are defining the time rate of change of velocity is called as acceleration. So acceleration is defined as the time rate of change of velocity. So in that instant we can define, if we are going to define or if we are going to imply acceleration by the term A, then this A is going to be equal to delta V by delta T. In such a case, in our case, what we have assumed for this vehicle, it is just 20 km per hour to 6 seconds. So how to calculate? Whether this unit is much bigger, that is specified in kilometer per hour. So we need to specify the time in second because we will be working with SI unit. Then how to just change the unit? 20 km per hour means in 1 hour we can write. Very simply if I talk. Then divided by what is there? 6 seconds is there. Let it write. Now we are shifting ourselves from this bigger unit, that is kilometer per hour, to meter per second. So 20 km means 20 into 1000 meter. 1 kilometer is equal to 1000 meter. That's what we are going to be introducing. And 1 hour is equal to how much? Second. That is 3600 second. And this divide is going to change into, then the 1 second, 6 second is going to be changed as 1 by 6 of second. Now if we cut to 0 here, so definitely we are going to find 580, and then by 2 if we cut 10, and then really 9 we are going to get, so we are getting 50 by 960 meter per second square. You can observe here the unit has changed to meter per second square. Why? Because 1 second and another second is lying. So second into second is equal to second square. We can also denote this meter per second square in this form, like meter per second square. In this way also we can differ. So this is the acceleration that we define. So what is the acceleration? Acceleration is a quantity of change in velocity with respect to time. Means in over a time, if the velocity is changed, that will be said as acceleration. Next, acceleration. If I talk about such kind of thing, like I just change my speed from the 60 km per hour to 80 km per hour. That means I have increased my speed. In such a case, I have mentioned it as acceleration. But what else? If I change my vehicle speed from, suppose 60 km per hour to 20 km per hour, that means on braking the vehicle, that can happen. At that time, what do we call it as? We call the total quantity of acceleration as delta V by delta T, where delta specified, that changes. Again I am telling that delta V is equal to Vf minus Vi divided by total time taken. Total time taken was the same, or suppose this is 10 seconds. In over 10 seconds, it has reduced to this speed. Then what is the total change in velocity? The total change in velocity, this is the final velocity. You can know, because finally we are getting this velocity, and initially when the case starts occurring with us, it had a velocity of 60 km per hour. That's why in such a case we find 20 km per hour minus 60 km per hour divided by 10 seconds. Then you acknowledge yourself the upper hand quantity of Vf minus Vi, and this Vf minus Vi is just less than 1. That means the quantity of delta Vi is negative in such a situation. In such a situation, the quantity delta V is negative. Why? Because we are just deaccelerating ourselves. Deaccelerating in the terms of that we are reducing our vehicle speed. That means the speed is just reducing, that the speed is falling down, and that time we introduce it as deceleration or retardation. Deceleration means deacceleration. When the acceleration occurs in a negative sense, that means instead of increasing velocity, it is just decreasing the velocity. At that time, we define the acceleration as a special quantity, that is deceleration, or we say it as retardation. Here also, in case of acceleration, also we can find average acceleration and instantaneous acceleration. By the way, that we will be specifying in our next class with a graphical representation of motion in a straight line. So hope you have enjoyed this video. Actually, I also faced little problem because I have never faced such kind of camera to teach the students. Really, it was very tough. It was very tough, and it was my first session. Hope I will be improving myself also, and you will enjoy my classes over YouTube here. Okay, thanks for being with us. Hope you have enjoyed, and stay tuned for the next video that will be coming very soon. Thank you.